Howdy, team, and welcome to this third video of our first day of talking about the tree data structure. And in this video, we're going to talk about how to traverse a tree. So we have just recently in class talked about iterators and the ability to go through every piece of data in a collection. And that looks differently for trees and for maps and uh, well, we have talked about lists and maps and other data structures, stacks, decks, etc. And now we are going to talk about how you traverse a tree. How do you see every element in the tree? There are three general ways of doing that. So I had mentioned that you often want to iterate over every element in a tree. And maybe that's you want to print it out, or maybe you want to find something, or maybe you want to uh, insert something. But in order to do that, you need to figure out where it's going to go. And so you need to iterate over and somehow look at the data that's in a certain node. So that's what I mean by process the node. You need to look at it, see, is it what I'm looking for, or print it, or do whatever it is that's necessary with that piece of data that you have retrieved. Um, so some of the terminology of what it means when you are traversing, it is often said you are walking a tree and visiting the node. So to visit the node um, means to read its data and use that in some way, in a comparison, in a print, in a something. Um, so you walk the tree and you visit the nodes. This is called tree traversal. This is a very, very common thing. You will need to write this many times in your career. As I mentioned, there are three general types of binary tree traversal. The first one is pre-order, the second one is in order, and the last one is post-order. We're going to be talking about all three of these. Um, and these are describing the walk, like how you're going to do the walk. Um, and they determine how, like, imagine you are a node, you have yourself and you have your children. In what order do you include yourself? So in a pre-order traversal, that means you're going to visit yourself at a different time than in a post-order traversal, for example. So let's talk about those a little bit more. So when you can visualize a tree traversal, the word walk is really helpful. You can just imagine that a little mouse is walking around the outside of the tree, and during that walk, um, it's visiting each node in a specific time. So if the mouse always keeps the tree on its left, then this is a route called a Euler tour, or so the mouse like turns around and goes up and down, but it's always keeping the tree on its left. So it's sort of like tracing it all the way around. The pre-order traversal means that the mouse is going to return or record or officially visit to the node. That means look at its data. It doesn't mean that it is like seeing the node for the first time. It is recording it, visiting it, looking at the data of the parent node or a node the very first time that the node is there. In an in-order traversal, we're talking about binary trees. So an in-order traversal, it is going to visit the parent or the root node after it has traversed the entire left subtree, but it hasn't done the right subtree yet. And a post-order traversal means that it is going to record the node or look at the data that's inside a node only after it has recorded and traversed both its left and right subtrees. So in a pre-order traversal, it's like I'm going to do the parent first. In an in-order traversal, it's like I'm going to do my left child, but not my right yet. And then in a post-order traversal, it's use the or visit the parent last. So let's see a little bit of the code for a pre-order traversal. So here, if the tree is empty, we are going to return. Otherwise, we're going to visit the root, then pre-order traverse the left subtree, and then pre-order traverse the right subtree. Let's make an example here. I'm going to use Harry Potter characters, of course. So I'm going to have Harry as the top node. I am going to have his two best friends, Ron and Hermione, here. And then Ron is going to have, let's say, Fred and George. And Hermione has her cat, Crookshanks. All right, so let's pre-order traverse this tree. So we're starting at the first node. We're looking at Harry right now. If the tree is empty, this is our base case. This is a recursive definition or recursive function. So we're going to look at Harry. Harry is not empty. So we're going to go into the tree and recurse. So we are going to visit the root. In this case, we're just going to write the character's names in order. So I'm going to write Harry because I am visiting the root right away. Then I need to pre-order traverse the left subtree. So I'm going to go to the left subtree. Maybe I will change color now, maybe to blue. So now I am recursing down to Ron. I'm looking now at Ron and I'm restarting the algorithm. So is this empty? No, it's not. It has some data. So I need to go into the else statement and I need to visit the root, which is Ron. So I said that visiting means that we're actually going to write it down. So we go to Ron, and then we need to go to Ron's left subtree. So I'm going to go there. Is it empty? No, it's not. It has some data. So I visit that data or I print it. I'm going to write Fred. And now I start the algorithm over. And, or it is going to go to the left subtree, which is null. There's nothing here. So I'm going to the left subtree here. If the tree is empty, we just return. So we're using our base case for the first time. So now the mouse is traveling back up. And now we need to traverse the right subtree. We're going to go down like that. We start the algorithm over. Is the tree empty? Yes, it is. So now we just return, and by returning, the mouse goes back to Fred. Now Fred has completed the traversal of the left subtree and the right subtree. So the node Fred, now we can return there. We're going back to Ron. Ron has another child. It goes to George. So we're going to restart the algorithm at George. So at George, we check to see if it's empty. It's not. So we're going to visit the root. Visiting for us means writing it down. We're going to go to George. From George, we are going to visit its null left and right subtrees. We've just done that with Fred, so I'm just going to draw the arrows of how we are traveling or how our mouse is doing so. We go from George back to Ron when George is finished. Now, Ron has visited the route. It has pre-order traversed both its left and right subtrees. So now Ron can return as well. And now we're back to Harry. Harry needs to check its right subtree. So Hermione is going to get visited, and then we can visit the imaginary left subtree, which is empty, so it just gets returned. We visit the right subtree, which is Crookshanks, and we add those arrows. Crookshanks is now going to visit its two null or empty children, so it's going to visit there and visit there. The arrows, remember, are the little mouse that's traveling along the tree. Crookshanks, once its left and right subtrees are finished, remember those are just going to return really quickly. So then we can go from Crookshanks back to Hermione because Crookshanks has finished its traversal. Now, with Hermione's right subtree being complete, or the traversal of it being complete, Hermione can then return back to Harry. And now with Harry's right subtree being complete, we have finished the entire traversal. So when we go through this um, tree, we went through the characters in this particular order. So I am going to try to delete just the blue stuff. All right, maybe the blue and some of the red. Forgive me, I'm trying to go fast. Okay, so if this is our tree, I am going to switch back to red. Okay. I am also going to see if I can shrink this. Lovely. Um, Interesting. Can I shrink it? Well, I can move it. How about that? And I will get all of this and move it here. Okay. Hopefully that won't disturb our other traversals. Okay, so quick moving here. Here is another example of our pre-order traversal, this time with just some letters, A, B, C, blah, blah, blah. You can see that they are A, B, C, D, E, F. So each level moves on to the alphabet. So if we are doing a pre-order traversal, that means that we are recording or printing or visiting the node the first time we see it. So we are going to record A first, and then we visit B. We're recording it the first time we get there. Then we move to the left subchild again. We go to D. D doesn't have another left subchild, so we're going to go to its right subchild, which is G. And then G doesn't have any children, so we can't really, when we traverse them, we're not going to record anything. The next thing so we go all the way back to B. Then we visit E, and then E's left subchild is H. After H, we can't visit anymore. E doesn't have a right subchild. So we go back to B. B has visited both of its children. It goes back to A. A needs to now visit its right subtree. So it goes over to C, and then it's going to visit the left subchild first. So we're going to get to F. F is going to visit I. I doesn't have any subchildren or doesn't have any children. So that will just, each of those children will just return for being empty. We go back to F. F goes down to J again. Um, J goes back to F. F goes back to C. C doesn't have a right subtree. So it goes back to A. And now we have finished the whole traversal. I know that I kept all of the markings on as I went through that example. I hope that's okay. So now we are going through an in order traversal. So let's get our Harry again. Okay, close enough. And let's traverse an in order traversal. In an in order traversal, you're going to traverse left first. So you're going to visit the left child, then you are going to visit the root or the parent, and then you are going to traverse the right child. So here in our Harry Potter example, we are going to have we're going to see Harry first. So we're going to start here, but we can't record him yet. We can only record him once we have visited his full left subtree. So we're going to go next to Ron. We're not going to officially visit Ron until we have done his left subtree. So we're going to do his left subtree, which takes us to Fred. Then we're going to do Fred's left subtree, which is null or empty. So now we can finally record Fred. Then we go to Fred's right subtree, which is empty, and then we return there. From Fred, we go back to Ron, and I'm going to write Ron there. It's starting to overlap things. Apologies. So we have now visited Ron. Now we need to visit Ron's right subtree. So we are going to do that. We're at this node that is George, but we are not officially visiting George yet. We're going to go to George's left subtree first, which is empty. So when we go back, we can record George. And then we go to the right subtree, which is empty. We don't record anything. George then goes back. George then goes back to Ron. Now Ron has investigated or traversed both his left and right subtree. He has visited himself. And so the subtree rooted at Ron has gone through the full um, in order traversal. Now we're going back to Harry, and we can finally record his name. From Harry, we're going to go to Hermione, but we're not visiting it yet. Hermione has a null right sub or left subtree, so it's just going to return. Then we can write Hermione's name. And then Hermione will visit her right child, which is Crookshanks. And Crookshanks would have before that explored that it had a empty left subtree. So then we would be able to record Crookshanks. Then it would explore the null right subtree. It would return, and then Crookshanks would return to Hermione. Hermione has already been visited. Hermione will return to Harry. Harry has already been visited. And we finish the in order traversal. So I am sure you are excited that I'm going to clear all of that. And let's look at the in order traversal here with their A, B's, and C's. So in this case, I want you to take a second, think about what is the first node that will actually be recorded. Take a second to think about it. Okay, let's find out. So in an in-order traversal, remember we are going to visit the left subtree before we visit the parent node. So here we are going to visit B, and now we go left again, and we go left again. But when we go left from D, it is a null subtree. So we just return and then we record the parent. So the first one we are going to record is D. So we record D and then we go to its right child, which gives us G. Then we are going to go back from D to B, and we'll actually get to record B now. And now B will go to its right subtree, so it's going to go to E, but it's not going to visit E yet. E is going to go down to its left subtree, which is H. H, it doesn't have any subtrees itself, so those will just return, which will return it to E. We'll finally get to record E. E is going to visit its right subtree, which is empty, so we're not going to record anything there. Then we're going to go back to B, who has already been visited. So then we're going to go back to the root, and we finally get to record the root, which is A. Finally, we're going to travel again. We are going to the left subtree or the right subtree. And from there, we need to go to the left subtree again. So we're going to go to the left to F. We're going to go to the left to I. From I, we go to the left again. It's empty. Then we record I. We go to the right again, and that's empty. So we're able to go back to F. From F, I'm going between drawing and clicking, and that is not making PowerPoint happy. So we go back to F, we can visit it again. Then we need to go, or we're visiting it, recording it for the first time. From F, we go to its right subtree after recording it, which takes us to J. We haven't visited it yet. We have to go to its left child first, which is empty. So then we can record J, and after J, we return to F, which has already been recorded. We return from F. Now that we have done both its left and right subtrees, we go up to C. We can finally record that. And that is the end of an in-order traversal. I want to point out something. I am going to draw a line for each node. So an in-order traversal is really convenient because it is going to return the nodes to you in left to right order. So D is the leftmost node here, and it is the first one recorded. The next line goes through G, which is the next one recorded. B is next, then H, then E, and the root here is A. That is next. So we're just moving from left to right and recording the nodes in order. So if you have an in-order traversal and you have a visual representation of the tree, you don't even need to follow the process. You can just return them in left to right order, and you will get the order correct. So that's a really easy shortcut for us to go through. when we need to just do it manually in our heads. Okay, the last traversal is a post-order traversal. So this means you're going to visit both children before you visit the parent. I'm not going to do this one Harry Potter style, but I do, oh, I do want you to figure out the post-order traversal of this tree. Pause the video now. Okay, let's go through um, some of this together. We'll just do the, I don't know, maybe we can go through it all. Okay, so if it's a post-order traversal, I can't record A until I have visited both its left and right subtrees. This means that your root is always going to be the last value that you record. So A is going to be last. We know that. So now we're going to visit A's left subtree, B is going to visit its left subtree, D is going to visit its left subtree, it's empty, so we're going to visit D's right subtree, and we finally get to write something down. We have G. Now, G, we were only able to record it because it doesn't have any children. From G, we go back to D, and we're finally able to record D. D goes back to B, but B, we haven't investigated both of its children yet, so we can't officially record it. We're going to go down to E. We can't record E yet either. We need to go to H. Technically can't record H until we have seen that both of its children are null. Once we confirm that, we can record H. H goes back up to E. Can't record E yet. We need to investigate its null right child. But since it's null, it just returns without recording anything, and we're finally able to add E. Then we can go back from E to B. We have explored both of B's subchildren, or both of its subtrees, now its children. So we can record B. B goes back to A. Still can't record A. We need to go to C. Can't record C. We need to go to its left subtree, which is F. Can't record that. We're going to go to I. I, we would explore its left and right null children and not record anything. Then we can record I. From I, we go back to F, which I still can't record. So we're going to go to its right subtree, J. Its children are both empty, so we can record J. J goes back to F. We have investigated both the left and right subtree of F, so I can finally record that. Go back to C. C needs to investigate its null right subtree. So it's not going to record anything. We're able to then add C, and then we go back to A and we can finally record the root. Okay, that was a lot. Um, I hope this was helpful as you figure out how traversals work. In-order traversals are by far the most frequently used because they are really convenient in that left to right principle. If you're able to arrange it such that left to right will be sorted order, then your traversal will always be sorted, which is why in-order traversals are so common. All right, team. I hope this video was helpful. Moving on to trees in Java in the next video. Thanks, team.